So I work at Henriques. We're a Swiss company. Does things change? Yeah. So my name is Tiago Henriques. I'm the CEO of Henriques. Essentially, to give you guys a bit of an idea, a bit of context to my talk. We scan the internet and we get lots of data from the entire IPv4 space and some IPv6 addresses. We scan the internet 200 times a month, different ports. I'm assuming all of you know what an IP address is. At least you should be geek enough to know that you know what an IP address is. We scan 200 ports a month. We have over 100 million IPs that we've detected with services. This generates mostly like 1.4, 1.5 billion events per month. We monitor things like torrent downloads, all of those things, and then we sell this data to our customers, which can be, for example, an insurance company where a startup or a company goes to them and says, "Oh, I want cyber insurance, so in case I get hacked, you guys pay for it, and I don't take the damage for that." They then come to us and go, "Can you guys give us a digital archive of everything you have of this company, so we can give them a rating and we can quote them on a price for this cyber insurance." That's what we do. So for this talk, I grabbed one of our files and essentially looked at 1.5 million domains for Switzerland. We will also look at some specific cases. Our platform that we've built of distributed scanning allows us to have different types of views, from a microscopic view of a single IP address to a medium-sized view for a company or a country, and then a macroscopic view where I say, there is a new vulnerability in Apache 2.0, giving every single IP on the internet that's running that software. So it allows us to do all of that. So as I said before, I focused on 3 different pillars that, in my opinion, is what this country stands on, which is banking, insurance, and farm. A couple of months ago, we published this on our blog. It ended up on a couple of newspapers and all of that, where essentially we looked at Switzerland and we found factories exposed, elevators, water dams, electricity grids, all sorts of things. IPs still vulnerable to Heartbleed that belong to ISPs, things like that. You guys can go and read the blog post. It's pretty cool and gives you a bit of the state that Switzerland is in. We've also done one for Portugal, one for Nigeria. We've done a couple, essentially. So I thought, what's the thing that I can show you guys, that tells you, the state that's, from a web perspective, the state that Switzerland is in. And I thought, what's the most basic thing you can implement as a developer, as a sysadmin of a website, that can provide some security? And essentially I ended up on security headers. And we're going to look at, these 7 types of headers. One of them is not security related, which is a server header, but it's still pretty cool to look at. So I grabbed those 1.5 million domains we had, and I threw it into our platform, and I said, go and get the root pages for all of these, and give me all this information for these 1.5 million domains. Of course, our list sometimes has invalid domains because websites go up and down every day. So first things first. Most common server headers. Essentially, Apache still pretty much takes the lead. Even though Nginx is a much better server, it's personal opinion, but Nginx is much better. Essentially, Apache is still very much in the lead. Fun fact as well is that there are actually pretty older versions of Apache as well. Same thing for IIS. If you guys look over there, the lead version of IIS is 6.0, which is a pretty old version as well. So this already kind of tells you a couple of things. Web servers, their types of vulnerabilities makes it pretty easy to DOS stuff. You're probably not going to be hacked by it, but your website might be down for a couple of hours thanks to stuff like this. Second thing, most common security headers in Switzerland. Essentially, strict transport security is the most common one, followed by XSS, XFrame options, XContent, and then quantity security policy, where I aggregated, reported, and enforced, and then public key pins. I left on the other slide descriptions of what each header does, so then when I provide you with the slides, you guys can really understand what they do and how you can go back to your companies and implement this stuff. Because out of all of these, only CSP is an absolute pain in the ass to implement. Everything else is pretty easy and already gives you, a really basic level of protection. And also think about, next time you go to use a website, there is a website called securityheaders.io. Pop the URL in there and see what is the rating that website is getting. And if it's an F, do consider what sort of information you're putting in there. Because if this is the most basic thing a developer can do, and they're not doing it, think about, is the database being encrypted? Is the data being sent correctly? I'm not even looking at if there's SSL or not, because I know how it looks like and it's a freaking shame. But this is the most basic thing you can do as a developer. And if you're not doing this to your own websites and to your company websites, please go back and do it. So the pillars of the country, right? Banking. This is really bad, right? Because you see things like Bangkok and Falcon Private Banking. It's just freaking terrible. And even worse than that, if you guys try to do HTTPS bangkok.ch, it actually redirects back into HTTP. This is absolutely insane for a bank. They then bring you back into HTTPS when you log in. But the moment you hit a non-HTTPS page, JavaScript could have been inserted that fucks up your browser, and even if you're on HTTPS, it doesn't really matter. So a bank should never even have HTTP services, ever. But then I started thinking like, it can't be this ridiculous, right? The entire banking industry runs this country pretty much. So I started thinking, what if what the banks are doing wrong is that they're focusing on the e-banking website rather on their main website. So I did the same thing for the e-banking. And it gets a bit better, but still, no public key pins. CSP is understandable, and I'll explain to you guys in a little bit why. But still, it's a bit of a better picture, but just essentially explains what banks are thinking. They're focusing on the e-banking website, but they don't forget that people don't land on the e-banking. People land on their main website and then go into e-banking. And by the moment you land on the normal website, lots of bad things can happen that will then affect where you're going after. So, that thing, I'm not joking, it's really, really hard to do right. This guy, Troy Hunt, anyone ever heard of him? No? He's actually one of the best application security people in the world. He got it wrong on his website. He lost donations via PayPal to his project because of getting CSP wrong. Because for CSP to work, for starters, you need to have a really good, strong policy, because what you're saying is which domains can access stuff on the website and things like that. And so you need to, as a developer, implement it correctly. You need to assume that the browsers have the implementation correctly done, and all of these things need to really align correctly for it to work out. And what happened here is that Chrome actually had an incorrect CSP implementation. And for about, I think it was like 7 weeks, he lost donations because every Chrome user could not do a donation to his project. So CSP really is messed up. So be very careful, how you implement it. It's possible to implement it correctly. It just takes a lot of testing, a lot of reporting. It essentially takes one dedicated person to do it. Which brings us into this. Cantonal Bank Cyber Competition. It's what I decided to call it. Where essentially I grabbed all the websites of the cantonal banks instead of the main big ones, and I looked at it as well. And I have to say, congrats to Luzerner Bank, whoever that is. I never heard of them, but they're pretty cool because they're doing CSP. Maybe they're losing customers, or maybe their customers can't log in, but hey, that's pretty freaking brave. Whoever, if you guys ever meet these guys, please buy them a beer and then send me a tweet and I'll hook you up with the money. But do buy them a beer because that's brave as fuck. So I'm not even going to mention Vodwise Bank because it's just sad. And same thing for Banner. And these are banks, guys. Seriously, it's like, supposedly the most secure institutions in the world, or in the country at least. So insurance companies. Picture doesn't get much better. You get a funny one from Winterthur Group where they actually try to implement extreme options, but the way it's implemented is actually an invalid configuration. The browser just doesn't even follow it, so it's not really worth much. Same thing for CSP. These guys, you don't see much innovation for them, not even risking it. The picture just tells you everything you need to know. Pharma, same kind of thing. You get a couple of interesting things from Syngenta, but Jesus, look at Clarion and Ciba and even Novartis and Roche, and it's just extreme options. And again, these are not things that are going to protect you against everything. This is what I consider literally the lowest bar I can set for when I want to interact with a company or a website. Like, let's just see what security headers they have. And when you guys get home, go do the same things for your ISPs, your own banks, even your own company websites. Go question your security team. Why aren't we using this? This guy at this told me it was pretty easy to implement. Was he lying? You know, they'll tell you CSV is pretty hard, everything else, yeah, sure, it's fairly easy. Or at least they should, and if they don't, please, again, send me a tweet. I'm happy to come in over and have a chat. If you guys go to that website over there, there's a huge list in there of domains for doctors, doctor websites and things like that, just here for Switzerland. And I decided to also look at all those domains. And again, same thing, out of 130, this is the implementation that we have for security headers. And these are the websites where, you know, if you're sitting at Starbucks, you're, you know, trying to do a doctor appointment, you're putting your name, you're putting your phone number, you know, sometimes in the photo, you're, you know, sometimes you write on the message the disease you have, things like that. So you don't, at least for me, I wouldn't want other people, you know, just knowing that, like, in the open. And, you know, I think people should be careful about these sort of websites because they should be the ones most secure because it's really personal information. Data leaks. Who here knows what a data leak is? Alright, so essentially, hackers hack stuff. Ta-da! They then, after they hack these companies, they grab their databases, they put it open into the world. Binary Edge, as lovely people that we are, we collect all of these databases, we bring it into a central database, and then the people that, you know, we sell stuff for, they can come up and say, these are our organizations, please tell us if you found anything on the darknet. And they'll go like, yay, here's what we have. Does this affect organizations in Switzerland? Banking, 26,763, 14,262 for Credit Suisse, and you guys can read. What this means is, for LinkedIn, Dropbox, Ashley Madison, dating websites, for these organizations, the users and their passwords have been exposed. Now, what do you think happens if the sysadmin of a bank, you know, gets caught on a cheating website, and essentially the guys go to him and say, you know, give us a couple of passwords or plug this thumb drive, or we'll tell your wife that we found your data on this website. Gives you a bit to think about, right? That happened in the US. It actually led to a couple of suicides by a policeman and someone else I can't remember right now. But this stuff happens in the real world, and this is something organizations, and again, if you guys work for companies, so make sure you monitor for stuff like this, do happen, because people that work in your companies can get threatened, they become internal attackers, and things become really complicated. Insurance companies, same thing, couple of data leaks. One of the smaller insurance companies didn't have anything, which is pretty cool. Same thing for pharma. In case of pharma, probably wouldn't be blackmail in the sense of getting access, but it can be like another company from competition goes to the guy, you know, we've got this on you, please give us, you know, some formulas or whatever pharma companies do. I have no clue, I don't do pharma. But yeah. And what websites were leaked? This is just the ones that affect like these three industries right now. Ashley Madison being one of the most critical ones. For those of you that don't know what Ashley Madison is, as a guy or a girl that you're married, you go into this website, you put your name, they find you someone to go on a date with that knows you're cheating, things like that, don't give a shit, they get paid for it. So that's what Ashley Madison is. That's why it's one of the most critical ones. Same thing for Adult Friend Finder, Fling, Badu as well, I think it's a dating website. But yeah, you've got bankers from Switzerland, from UBS, Credit Suisse, things like that, that were registered on this website. Why they were using their organizational emails? I don't know. So, other thing that we do is, we scan the entire internet, and then we've got modules on our platform that look for specific things. In some of those modules can ask for status information. Status information from databases service, for example. In this case, we're talking about Redis. And we essentially scan the entire internet, IPv4 space, and we ask every Redis, give me your status. And one of the things that comes in the status from Redis is how much memory they have stored. At this point in time, which was actually last year, I'm sorry I didn't have new scans, but as I said, I started doing the talking, so please forgive me. I can give you updated numbers at some point. But this was last year. Only Redis was exposing 17 terabytes of data. And this is data that, like, no authentication. If you know how to use Redis client, you just go Redis client, IP address, and you connect to the Redis server, and you can check everything that's stored on those Redis. And in total, it was 17 terabytes of data that were stored. Next up, MongoDB, 619 terabytes of data. Cool thing, MongoDB replies with the name of the databases and the collections. And one of the funny things we noticed is that there was a collection, at some point, someone went and did a scan just like ours, but they actually had a very special script running that every time it was able to connect to a Mongo, it would delete their entire database and just create a new one named deleted because you didn't password protect your MongoDB. This guy did everyone a favor. For starters, you got rid of MongoDB, which is shit by the way, and then you guys should really protect your databases. Next up, Memcached. Memcached, 11 terabytes of data. Same thing, spread all over the world, lots of really old versions, your typical stuff. For Memcached, it was pretty cool actually because we found one of the banks had their main website, the Memcache that was serving the ads for their main website was fully open. What this means, if a really evil hacker wanted, they could go into their Memcache, inject a small piece of JavaScript into that would then leak your cookies and things like that back to him, and he wouldn't even need to find out your password to log into your bank account. Well, still he wouldn't even have to deal with two-factor authentications because the cookie would get generated and he would be able to get access to that. But essentially, yeah, we reported that to them, they were a pain in the ass, but they fixed it in the end. Last up, and this was the most scary one, Elastic, 531 terabytes of data. This was really big. Elastic is used to store massive logs, so it wasn't really surprising. Essentially, in all of these databases, we don't get the data that's in there, because as I said, we only asked for the status. If we asked for data that's inside the database, that would break a law, and we wouldn't be able to do that because we would be hacking the company. We're literally only allowed to ask the status, and we have to work with whatever the status returns to us. And what you do get in the status is you get the databases names. And we found that there were robotic companies that had their blueprints in there. We found out lots of intellectual proprietary data from different companies that literally, if anyone from the competition wants, can hire a bunch of hackers and just steal this off. One funny thing. So as I mentioned, we do this every month. We scan 200 ports a month. And we noticed something really, really funny. Martin, where's your pointer thing? Can I have relax?
Yeah.
All right. Martin, where?
Yeah. Jesus Christ. Oh, sorry. I have to turn it off.
You're gonna blame me, ass. Anyway.
Hacker.
I said in CEO. I don't know. Now, so if you guys notice over there, from August, we had, I think it's 13.2 terabytes of data exposed via Redis. And then there was a huge change over here. And we never actually found out why, but some other guys did. Essentially what had happened with MongoDB, a guy did it for Redis. But he was actually pretty cool. Why? Because he created the first data, at least that I'm aware, first database ransomware. Because he logged into the Redis, he encrypted all the data, created a new entry with just the contact information, and essentially said, pay me this if you want to get the key to unencrypt all the data in your Redis. Instead of deleting like the other guy, he created the first database ransomware. So that was pretty cool. These guys found out about that, and we correlated the data, and it was pretty interesting. Oh yeah. To finish up, in case of Switzerland specifically, we looked at categorizing the industries that were exposing data. Software development was the biggest one, so software houses, startups, things like that, followed by miscellany that we weren't able to classify, public institutions, IT companies, media, website, lots of adult websites exposing user accounts, emails, things like, if you go on an adult website and you say, what's your favorite sex thing? Things like that were exposed, all sorts of stuff. It also happened for Ashley Madison, by the way. All the sexual preferences for all the users were also leaked. We wrote a pretty cool blog post about that, by the way, because we're a data company, we're not a cybersecurity company, surprisingly enough. So check our blog post, check the Ashley Madison post, it's pretty interesting. And yeah, that's me. And there is no Q&A, so I guess next person. Thank you.